Uh, Hello everyone, a very good evening to all. So, can you all see my screen?
Yes, sir. Yes, sir.
Okay, so we will start now. Just give me a few minutes. Hello everyone, a very good evening to all. Myself Vivekananda Naik. I once again welcome you all for this third interaction session on atomic and molecular physics, which is being flowed this January 2025 session on NPTEL with a course code NOC 25PH04. So myself Vivekananda Naik, I am a PhD research scholar in the Plasma Physics Laboratory at Department of Energy Science and Engineering, IIT Delhi. So let's start today's discussion. So talking about the concepts covered in this week's lecture, that is week 3's lecture. So the lecture was related to the advantages and disadvantages of Bohr's theory, which gave path to the theory gave by Sommerfeld in accordance to the disadvantages that Bohr's theory encountered. So we also some also discussions were related to the spectra of alkali atoms, and G-Man and Stark effect was also there, was briefly discussed, which are mainly the disadvantages of Bohr's model. So now continuing our discussion from the last class or the last session, we had two remaining problems from the last week's lecture. So the question says, question number 10. So you can all see my screen clearly. Okay, so the question was, the sun gives maximum emission at the wavelength of 5500 Armstrong. Estimate the temperature of the sun considering that the sun is a black body. Given Owen's displacement constant is 3 into 10 to the power minus 3 meter into Kelvin. The options are option A 5500 Kelvin, option B 55 into 10 to the power 4 Kelvin, 5454.5 Kelvin, and option D 15,000 Kelvin. So now, as you can clearly see, the question says the sun gives maximum emission at wavelength 5500 Armstrong. So this question is related to the Wien's displacement, Wien's law, and it says with increase in temperature, the maximum wavelength corresponding to the maximum wavelength correspond to the maximum emission or maximum emissive power decreases. So now, according to the Wien's displacement law, the formula is lambda m into T equals to B, or we can say lambda m is right proportional to 1 by T, and B is the Wien's constant, which is given in our question. It is 3 into 10 to the power minus 3 meter into Kelvin. Now the question says estimate the temperature of the sun. So we have the value of lambda, we have the value of B. So simply we need to calculate the temperature of the sun. So what will be the temperature of the sun? It will be T equals to B divided by lambda m. So B, we know B is 3 into 10 to the power minus 3. So as you can see, wavelength is in Armstrong and the displacement constant is in meter into Kelvin. So we need to convert Armstrong into meter, and since all the answers are in Kelvin, so we don't need to convert anything. We don't need any conversion for Wien's constant. So now if you calculate, so it is meter into Kelvin, and then lambda m, that is 5500 Armstrong. So 55 into, we know 1 Armstrong is 10 to the power minus 10 meters. So 10 to the minus 10 meters. So meter gets cancelled out. So the remaining answer will be in Kelvin. So it will be 3 into 3 divided by 55 into, this is 10 minus 10 minus 3. So it will be 7, and then these two zeros will be getting cancelled. So it will be 10 to the power 5 Kelvin. Now if we calculate it, it will be 3 divided by 55 into 10 to the power 5 Kelvin. So if you calculate, it will give you. So 3 divided by 55 is 0.05454 into 10 to the power 5. So into 10 to the 5 means it will be 5454.5. 5454.5 Kelvin. So this will be the answer, and the correct answer is option C. Is this clear to everyone? Okay, so we will now move to the next question that was remaining from the previous session. The question was, a spherical black body of radius 10 centimeter radiates 500 watt power at 500 Kelvin temperature. If the radius being halved and the temperature is doubled, then the power radiated in watt will be. Options are option A 8,000 watt, option B 4,000 watt, option C 2,000 watt, and option D 500 watt. So can anyone tell me this question is related to which law? Sorry, I can't hear you properly. Yes. Okay, so if you remember the discussions from last class, we had discussed. So the total power radiated by the black body is governed by Stephen's law. So Stephen's law says, what does Stephen's law say? It says the total power radiated by the black body is directly proportional to the fourth power of the temperature. So now here the question says a spherical black body of radius 10 centimeter. So if the radius is 10 centimeter, and we know for a sphere, what is the total surface area?
4 pi r square.
Yes. So the total area will be 4 pi r square. Now if we uh, want to calculate the total power radiated by the black body of that area, so what will be the value at a particular temperature? The value will be sigma T to the power 4 into area, which is the total power, because the power density is power density means power per unit area. Power radiated per unit area is equals to sigma T to the power 4. So total power radiated is sigma T to the power 4 into pi r square, or the area of that sphere. So now if we do that, so uh, according to the question, it is 500 watt. And if we take sigma, because sigma remains the same, so we don't need to give any subscript to the value of sigma. Now for first case, suppose the temperature is T1, so it is T1 to the power 4 into 4 pi R1 square. Now this is the given condition we have. Now again we have R1 is 10 centimeter, and T1 is 500 Kelvin. Now if we want to similarly, if we want to measure the power radiated by the body for another case having temperature T2 and radius R2, then what will be the value? Then it will be total power E2 will be equal to sigma T2 to the power 4 into 4 pi R2 square, is not it? So this is equation 2, and the previous one is equation 1. Now if we divide equation 2 by equation 1, equation 2 divided by equation 1, then it will give us E2 divided by 500 is equals to T2 by T1 to the power 4, because sigma will cancel from both the equations, because sigma remains the same as it is an universal constant. Now also 4 pi will get cancelled, and we will get R2 divided by R1 square. Now, according to the question, it says if the radius is being halved and the temperature is doubled, so T2 is 2T1 and R2 is R1 by 2 because temperature is doubled and radius is halved. So if we want to calculate, then what will be the relation? So E2 divided by 500 is equals to, so T1 was 500 and T2 is now twice of that. So T2 by T1 will be how much? T2 by T1 will be, so from here T2 by T1 is equals to 2. So it will be 2 to the power 4 into, now from again from this condition R2 by R1 will be R2 by R1 is 1 by 2. 1 by 2 to the power 2. So it is 2 into 2 into 4 into 1 by 2 into 1 by 2. So these two 2's will get cancelled out, then it will be 4. Now E2 will be 4 into 500 watt, which is 2000 watt. So the power radiated by the body, if its radius is being halved and the temperature is being doubled, the correct answer is 200 watt. That is option C. Is this clear to everyone? Okay, so now we will move to the questions that are related to this week's lecture, like the advantages and disadvantages of Bohr's theory. So now discussing the first question of this week's lectures. The question says the drawback of Bohr's model is, options are option A, it was valid only for single electron atoms or ions like H, helium positive and lithium double positive, etc. And option B is fine and hyperfine structure can be explained by Bohr's model. Option C can't explain the splitting of lines in presence of electric and magnetic field. And option D, all of the above are true. So can anyone tell me what will be the correct option?
D1, sir.
Okay, so if we talk about Bohr's theory, so Bohr's theory was able to explain a few things. For example, what will be the radius of the orbital when electron is revolving in that orbital? What will be the orbital velocity? What will be the energy as long as electron is revolving in that orbital? Again, it gave idea about the emission and absorption spectra, because according to Bohr theory, the electron can revolve only in those stationary states where its angular momentum is quantized, which is given by the relation mvr is equals to nh by 2 pi, that is multiple integral multiple of h cross. And again, it is said that as long as the electron revolves in a particular stationary state, also from the name you can say we are saying it stationary states because it has a stationary energy, that is a constant energy value. So as long as an electron is revolving in a particular state, its energy remains constant. So however, with different energy states, it has different energy. So if we know the ground state has the minimum energy, which is minus 13.6 electron volt, for example, for hydrogen atom, and also we can calculate for hydrogen like atoms also. However, if we consider about the hydrogen atom, it said that as we go on to higher energy levels, the energy goes on increasing, that is minus 13.6, then minus 3.1, like that. So if an electron is if there is a transition and the electron is coming from higher orbit to lower orbit, then it will emit light. And if the electron is absorbing energy or absorbing energy in terms of photon, then it will go from lower to higher orbits. So that difference in energy is getting emitted and is getting absorbed depending upon the initial and final energy values. So these are a few things that Bohr model of hydrogen atom was able to explain. But if we talk about the drawbacks, The drawbacks were, again, it was valid only for single electrons. Why it was not valid for multi electrons? Can anyone say? Yes. So if you remember, during the Bohr's theory, when we calculated different um, uh, formulas like for orbital radius, orbital velocity, and all, we balanced two equations or two forces basically. One was centrifugal force, another was force of interaction between Coulombic interaction force between electron and the nucleus. And there we only considered only one electron is evolving. So if we assume there are more than one electron, then the derivation will be different, and that's why the formulas that we have already calculated is only valid for single electron atoms. For example, when the atom has only one electron, it may have more than one proton, which is true for helium plus and lithium 2 plus. However, those atoms have only one electron revolving around the nucleus. So this was not explained by Bohr's theory. How for multiple electrons, how we will calculate these things. And again, if you consider about the fine and hyperfine structures, these are also were not explained by Bohr's theory, because fine structure, basically these are normal spectra like hydrogen spectra. But if you see, each line consists of a number of lines. So if you talk about there are H beta, H gamma lines. So we have also H alpha 1, alpha 2, H beta 1, beta 2, like that. But these were not explained by Bohr's model. And again, this is related to the option A, because again Bohr's model was only valid for one electron. So when fine structure, can anyone tell me when fine structure appears for an atom?
When they
So
transit from higher energy to lower energy.
no, that is spectra, emission spectra. But fine structure appears when we consider the coupling between spin and orbital motion of electrons. Because Bohr's theory was only related to the motion of electrons in a particular orbit, so there was no discussion about the spin interactions, spin momentum, and orbital angular momentum and orbital spin momentum. That's why it was not able to explain the fine structure, because fine structure mainly comes due to coupling of L and S. L is the azimuthal quantum number or orbital quantum number, and then S is the spin quantum number. Again, if you talk about hyperfine structure, again hyperfine structure comes due to nuclear spin. Like fine structure comes due to electron spin, hyperfine structure comes due to nuclear spin. So these sorts of things were not explained by Bohr, because Bohr only considered only one quantum number, that was principal quantum number. And principal quantum number, like last session we were discussing, principal quantum number is only related to the energy value. As long as the principal quantum number remains same, the energy remains constant. Also, from if you have gone through the lectures of these weeks, you must have seen, although there were modifications related to Sommerfeld's new rules of quantization, the expression for energy, if you see, the dependence on n is fixed, because for a particular value of n, energy remains the same. So there are not other quantum numbers were not taken into picture. That's why there were no discussion about fine and hyperfine structure. So again, this was also one demerit of Bohr's model. And if you talk about the splitting of lines, it was also, it again was not able to explain the splitting of lines in terms of electric field and magnetic field, because these things play an important role if you talk about the orbital angular momentum. Because in that case, there will be, so generally this effect in presence of electric field, it is called as Stark effect, and in presence of magnetic field, it is called as uh, G-Man's effect. So these things only comes into picture when you talk about the magnetic moment of atom, and that magnetic moment of atom is again related to the orbital motion and spin motion. So as long as you don't discuss these motions, you discuss only about the motion related to the orbitals, or related to the stationary state. So there will be no discussions related to the splitting of lines, because the splitting of lines are due to the effect of those magnetic field and electric field on the orbital and spin motion of electrons. So again, this was also not explained by Bohr's model. So what will be the correct answer? Eventually, the correct answer comes out to be option D. That is, all of the above are true. So now is this clear to everyone? Okay. So uh, once again, I would like to say your voice is not clear. So it will be better if you can choose any other medium. I can hear you, but your voice is again too feeble. I can anticipate a few things you are saying, and then I can realize. But I am not being able to hear it clearly. But anyway, I will try. We now move to question number two. Question number two says, compute the de Broglie wavelength of an electron whose kinetic energy is 25 electron volt. Options are option A 5.02 Armstrong, option B 2.45 Armstrong, option C 1.33 Armstrong, and option D 0.56 Armstrong. So, can anyone tell what will be the de Broglie wavelength? So, I'll give you a few minutes so you try and tell me what will be the correct option.
Sir, can we use a scientific calculator in the exam?
That I think I don't know exactly. You know about the discussion forum for that particular course?
Sir,
There is a
this was my first this was my first class as I have
no, no.
enrolled here.
Okay. Okay. So,
And
if you have gone through the instructions provided to you by the NPTEL team,
usually usually in hall tickets they will mention as no electronics device will allowed for any competitive exams like online examinations. Then
yes,
like this problematic part we need
yes,
scientific
I
calculator.
that
We
no,
thought
I thoroughly
yeah.
understand your doubt, but what I'm saying, so for each course that's being float on NPTEL, you have a discussion
Hmm.
forum where you can ask or post your doubts, and it will get clarified by the um, teaching assistants. And so, since I am only associated with these sessions, and I don't
Okay, I
exactly
have
yes,
okay, sir.
so you
Okay,
can
sir.
post your questions there, and they will be responding to that.
Okay, sir. Thank you.
Okay, so you solve it and tell me what will be the correct option for question number two.
2.45, sir.
Yes, the correct option is option B, that is 2.45 Armstrong. Anyone other was able to calculate it? Okay, so okay, so according to de Broglie's hypothesis, each particle is associated with a wavelength which is called as metal. Each metallistic particle is associated with a wavelength, and the formula to calculate that wavelength is given by lambda is equals to h by mv, where h is the Planck's constant and the value is, can anyone tell me what is the value of Planck's constant? So it is 6.62 into 10 to the power minus 34 joule into second. Now this is the formula where h is the Planck's constant, m is mass of that particle, m is mass, and v is the velocity. So now the question says compute the de Broglie wavelength of an electron whose kinetic energy is 25 electron volt. So basically there are different formulas for calculating the de Broglie wavelength. Now if we talk about for this particular case, since we don't have the expression for this v, because we know electron means we have the mass of electron. Can anyone tell me what is the mass of electron? Yes.
9.1 into 10 to the power of
Yes, 10 to the power of minus 31 kgs. So this is the mass of electron. Now we need to find out the value of velocity. But here the question says the kinetic energy is 25 electron volt. So if we try to use another formula, so we know the energy is given by p square by 2m. This is the relationship between the kinetic energy and the, where kinetic energy and momentum. This is the relation relating kinetic energy and momentum. Now if we talk about the expression, now under this relation the p becomes, so, so this lambda is nothing, so this mb is nothing but the momentum, that is h by p. Now if you use this relation, so p will be 2m into kinetic energy, suppose it is e, so is root over of 2me. So now this relation lambda becomes h by 2me root over. So now again the question says whose kinetic energy is 25 eV. So in order to get the value, so now here if lambda is in meters, then under SI units E should be in joule. However, the question says the kinetic energy is 25 electron volt. So again we need to convert 25 electron volt into joule. Can anyone tell me what is the formula for 1 electron volt, or what is the value of 1 electron volt in joule? So can anyone tell me what is the definition of 1 electron volt? So when we can say the electron has energy 1 electron volt? Yes. So 1 electron volt is known as the energy gained by the electron when it gets accelerated in a region of potential difference of 1 volt. That's why the unit name is 1 electron volt. So 1 electron volt is 1.6 into 10 to the power minus 19 coulomb into volt, and coulomb into volt is nothing but joule, so it is 1.6 into 10 to the power minus 19 joule. So basically this comes from 1.6 into the minus 19 coulomb into 1 volt. So when an electron is getting accelerated in a region of 1 volt, then according to its charge of 1.6 10 to the minus 19 coulomb, it will gain the 1.6 into 10 to the minus 19 joule of energy, and that is known as 1 electron volt. So there is a formula. So now here the kinetic energy is EV. So if you convert from electron volt to joule, so this is in joule and this is in electron volt. So there is a formula which is used to calculate the value of de Broglie's wavelength, which is, this is particularly for electron, it is lambda is equals to 12.27 divided by root v Armstrong. So how this formula is derived? So we know lambda is h by 2m e root over. Then if you put in place of e, we will put e into volt. So h is 2m e into volt root over. So we know the value of e, we know the value of m, and again we know the value of h. So if you put all the values and uh, express it in Armstrong, it will give you 12.27, sorry, 12.27 divided by root v, because all other quantities are constant, and this is Armstrong. So this is the actual formula that we were going to use in this question. So if you use that, so what will be the value? It will be, so lambda will be how much? So lambda will be 12.27 divided by root over of 25, because the energy is 25 electron volt. So it will be 12.27 divided by 5, which comes out to be 2.45 Armstrong approximately. So the correct answer is 2.45 Armstrong. Is this clear to everyone? Yes. So now, so is this clear to everyone?
Yes, sir.
Yes, sir.
Okay, so can anyone tell me whether this is the case of, sorry, I request you to mute yourself whenever you are not answering or responding to my questions. You just mute yourself, because otherwise there will be unwanted noises. So can anyone tell me uh, whether this case is for relativistic motion or non-relativistic motion?
Relativistic motion.
Sorry, once
For
again.
relative for relativistic motion.
No. So can anyone tell me, oh, when we say that the particle is under relativistic motion? So when the particle is moving at a speed which is closer to the speed of light, then we will say that the motion is relativistic. Now, if you talk about the uh, in mathematical sense, if the energy of the particle is comparable to its rest mass energy, then we can say it is moving at the speed of light, because the rest mass energy given by, so the rest mass energy E0 is given by m0 c square. So if you calculate the rest mass energy of electron, it comes out to be 100 keV. Can anyone tell me what is the rest mass energy of electron?
9.1 into 10 to the power minus 31.
No, no. I am talking about rest mass energy. It's not rest mass. So just multiply c square with it. So it is 551 keV. It's not 100 keV. It is 500. Sorry, 511 keV. So if you calculate, it will be 0.511 MeV. Now this is in mega electron volt, and the question which we are solving is in electron volt. So you can say the energy is very less than the rest mass energy. So the energy in our case is very less than the rest mass energy. So the velocity of the electron will be very less than the velocity of light. That's why this is the case of non-relativistic.
Sir, can you explain once again, please?
So we will say the particle is under relativistic motion when the velocity of the particle is close to the velocity of light, that is c. So if you compare, so generally it is compared in terms of rest mass energy, because rest mass energy relates the rest mass and the velocity of light. So the rest mass, we know according to mass energy conversion, according to Einstein's mass energy conversion, E is equals to mc square. So the rest mass energy will be, we know the rest mass of electron is 9.1 10 to the minus 31 kg. So the energy of the electron will be how much? Energy will be m0 into c square. So if you put the value of m0 is 9.1 into 10 to the minus 31 kg and c is 3 into 10 to the power 8 meter per second, then it will give you 0.511 MeV. So now if you compare the rest mass energy to the energy that the electron has in our problem, so it is the kinetic energy is 25 electron volt. So the energy is very less than the rest mass energy of electron. So since the energy is very less and energy direct proportional to the square of the velocity, so the velocity is very less than the velocity of c. So when the velocity is very less than the velocity of light, then we can say the case is non-relativistic case, or the electron is under non-relativistic motion. Is this clear?
Yes, sir. Yes, sir. Thank you.
Because if you talk about energy, what we did in this question, we converted the we used that this formula p square by 2m equals to e. However, if we talk about the case when the motion of the particle is relativistic, then under that case, let me add another slide first. So new slide. Okay, so uh, for non-relativistic case, the expression was h is equals to 2me root over. This was the case of non-relativistic. However, if we talk about the relativistic case, under relativistic case, the energy becomes E square, which is equals to P square C square plus M0 square C to the power 4. So in that case, what generally it was P square is equal to 2me for non-relativistic case. However, since now the relativistic case the thing is different, so it will be E square minus M0 square C to the power 4 is P square C square. So P square is E square divided by C square minus M0 square C square. So now you can see the expression for P square is different. This is relativistic case. So the expression for d wavelength will be different when the motion is relativistic. I hope this is clear to everyone. So now if we go to the next question, the question says,
Sir, one doubt.
yes,
That is one general doubt. For Einstein mass energy are mentioning that easy. Why we are mentioning
sorry,
that for Einstein mass energy equation,
yes,
E is equal to mc square.
yes.
The velocity of light means why we are mentioning as c square plus what does square mean?
What means? So, is this the problem on my side, or everyone others are also struggling to hear him or hear her? Sorry.
Can you hear me now, sir?
Now I can hear you. Say.
Sir, usually for Einstein mass energy equation, we are saying E is equal to mc square, sir.
Yes.
Where c is the velocity of light, 3 into 10 to the power of 8. Why
Yes.
we are mentioning it as c square, sir? What does it means for? That is why we are adding square there.
So these things comes when the motion is under relativity constant, because you see in this question we discuss about m0 c square, but when the particle is under relativistic motion, its mass does not remain the same. The mass changes from m0 to m. So under that influence, we can say m is equals to m0 1 minus v square by c square. That's why when the body is moving at a, it is, sorry, it is, I think, m0 into 1 minus b square by c square. So in general, the this is the formula for reduced mass. We say it as reduced mass because when the motion of the particle increases, the mass generally feels light, or the weight of the body decreases. So it is m0 1 minus v square by c square. So when v is equals to c, then the body has zero mass. So that's why you see there are two cases when this is the case of rest mass and this is the case for the momentum or the energy related to the relativistic motion. That's why there are basically two terms in that energy, in the energy term. So there are two different contributions.
Okay, sir.
Okay, so now we will move to the next question, that is question number. So there are two, one is rest mass energy term, another is the relativistic energy term. That's why there are two energy points, the two energy terms. So that's why if you are considering the relativistic case, since the energy does not remain the same, so the formula for de Broglie's wavelength will again be different. Now talking about question number 3, question says a positronium atom is a system consisting of a positron and an electron. Calculate the reduced mass of positronium atom given mass of electron is 9 to 10 to the power 31 minus 31 kg. Mass of positron is same as that of electron, and the charge is also same as that of electron, but it is positive. The options are option A 4.5 into 10 to the power minus 31 kg, option B 9 into 10 to the power minus 31 kg, option C 3 into 10 to the power minus 31 kg, and option D 18 into 10 to the power minus 31 kg. So um, I'll give you a few minutes. So solve it and tell me what will be the correct option out of these four. Otherwise, we will discuss.
Sir, can you explain this one?
Yes. So can anyone tell me what is the correct option? Yes. So generally, positronium atom means it consists of a positron and an electron. And what is positron? Positron has the mass equal to the mass of electron. However, the charge of positron is exactly opposite the charge of electron. So now, generally, what happens if basically the reduced mass is a concept of classical mechanics, we can say, because if we are talking about the system when there are a large number of particles, so suppose there are two particles, so in order to reduce the complexity of that problem, we consider a single particle which has a mass that is called as reduced mass. So it helps in solving only one equation rather than the case when we don't take any reduced mass concept, we need to solve two equations. So this is basically a concept which is quite helpful when you are solving a problem consisting of two body system. And the formula everyone must be knowing. The formula of the reduced mass is mu, which is m into m1 into m2 divided by m1 plus m2. So now basically if you talk about the center of mass concept, then you can say uh, when we convert from actual mass to reduced mass, then also the frame of reference or the the frame of reference will again gets changed. So from the expression of derivation, the we got the concept that was a value of reduced mass. So uh, basically this is the formula for reduced mass, m1 into m2 divided by m1 plus m2. So now since both have same mass, so we can say it is m into m divided by m plus m, that is m square by 2m, so which gives us m by 2. So the reduced mass will be 1 by 2 into mass of electron, that is 1 by 2 into 9 into 10 to the power minus 31 kg, which is 4.5 into 10 to the power minus 31 kg. So is this clear to everyone?
Yes, sir.
Yes, sir. Can you explain why we call reduced mass means?
Because you see the mass, again if there are two bodies, one is m1, another is m2. Now you can clearly see so it is generally it is a very basic understanding, but you can say the mass is getting reduced 1 by 2 into m. So this is called as reduced mass. But if you talk about the concept from where it has come into picture, so if you talk about the concept of center of mass, so if you talk two bodies and both and a particular suppose this is the case when there are two bodies and the body is connected from this point through a stick, or there are two balls. So if you talk about the inertia or the moment of inertia, then this will be the moment of inertia, this is m1 and this is m2. So if you talk about the moment of inertia also in case of the concept of the total energy of that system, so then the concept of reduced mass comes into picture. So if you derive the total energy, then we will see. So if you want, we can discuss it in the next class. Then what will happen there, we will see there are two terms. One term is a particular mass corresponding to a particular sorry, one term will be a motion of a body with mass mu, that is reduced mass, and another two term will be motion of the reference frame of reference. So from that we found that if there are two bodies, then the expression for reduced mass is m1 into m2 divided by m1 plus m2. So as you can see also, the effect of each mass is getting reduced in case of a particular another body which is have the mass that is less than the mass of the current bodies. So this is called as reduced mass. So we will discuss, if you want we can discuss it in the next session
Next,
where
okay, sir. In next section, we'll discuss about it.
exactly. Okay, so
What is the main basic concept of behind this one and why we call that one? And just confusion. I go through the
okay,
videos, even that has not clear, sir.
okay, we will definitely, that's the issue, then we will be definitely discussing that. So at the beginning of the session, just remind me, then we will discuss. But the
Sir,
basic
your
understanding.
all your interpretations are very clear, sir. So only we are asking the basic questions to you. Sorry
No, no,
if we disturb you, sir.
no, no. It's no. mm, I am more than happy when you are asking those questions, because I also want to explain you. I have different approach. So like this question in the last class also, you are talking about X-rays. So I discuss a few things. So if you want to discuss in more details, because the main aim of this interaction session is to interact with you and to clear your doubt. So basically the concept of moment concept of reduced mass comes when there are more than one particles and we are considering the motion of those particles. So if we want to so for every case when you are solving a problem, you talk about a particular frame of reference, either it is laboratory. So either it is laboratory frame of reference or it is center of mass frame of reference. So when we talk about the center of mass frame of reference or laboratory frame of reference, so if you calculate, if you convert from one frame of reference to another frame of reference, we'll found that the motion of two bodies getting converted. So if we talk about the motion of two bodies in laboratory frame of reference, and if you talk about the same motion in center of mass frame of reference, then we found that for two bodies we are seeing a particular body with a different mass and then the motion of the center of mass. So from that the concept of reduced mass comes into picture, and the expression we will find, the expression will be m1 into m2 divided by m1 plus m2 if there are two masses. Okay, so we will move to question number 4. Question number 4 says, in previous problem, what will be the value of Rydberg's constant if the value of Rydberg constant for hydrogen is 1.0974 into 10 to the power 7 meter inverse? Options are: option A 1.0974 into 10 to the power 7 meter inverse, option B 5.487 into 10 to the power 6 meter inverse, option C 1.0974 into 10 to the power 8 meter inverse, option D 1.974 into 10 to the power 7 meter inverse. So these are the four options. Calculate and tell me what will be the correct option.
Sir, option 2, 5.48.
Exactly, the correct answer is option B 5.487 into 10 to the power 6 meter inverse. So this is this question is related to the concept of reduced mass of nucleus, because in that case, sorry, this is a question of reduced mass due to the effect of the motion of the nucleus and motion of electron. So if we discuss about the model of hydrogen atom that was given by Bohr, so according to Bohr, uh, it was given that if there are transitions between the energy levels, the wavelength, frequency, and wave numbers were getting calculated, and from that we got a constant which was m e to the power 4 divided by 8 epsilon 0 square c h q. This was the formula for Rydberg's constant. However, so here you see if we talk about the concept of reduced mass that we solved in the previous question, so when there are two bodies again and they are in motion, so the mass of the total system, the effect due to the effect of this motion, the system, the mass, the masses present in that system, they get changed, and the effect is expressed in terms of reduced mass. So if you see here, the m is mass of, so m here, m is mass of electron that is taken in the current case. So it is mass of electron. However, for a electron revolving around nucleus, if we consider, so here we have considered the nucleus is at rest, and the nucleus is at rest and its mass is infinity. So if you see, due to the however, due to the motion of nucleus, the concept of reduced mass comes into picture, and the mass of electron is getting changed due to the motion, relativistic motion. So here in the, sorry, so here it was a positronium system, and there the mass was m by 2. So here in place of m we will use m by 2. So that will be the new Rydberg constant, that will be for positronium. This was for hydrogen atom. So actually, initially I was explaining you wrong, because that this question is related to positronium. However, if you talk about the nucleus, there was correction in Rydberg constant. So under that case, it was assumed that the mass of nucleus was infinite. That's why the reduced mass of the nucleus and electron system was taken to be equal to the mass of electron. However, we know the mass of nucleus is finite. So if we take the mass of nucleus is finite, and also there is relativistic motion between the nucleus is also in motion, nucleus is not stationary at a point. So there will be a system of relativistic motion of two bodies, which is electron and nucleus. Under that case, the reduced mass will again get changed, and this type of problem we will discuss in the upcoming times. We will be discussing this type of problems. So here, since the positronium, the reduced mass is getting different, it will be m by 2 e to the power 4 divided by 8 epsilon 0 square chq. So only m is getting changed to m by 2. So it will be half of that value. So RH divided by 2. So 1.0974 into 10 to the power 7 divided by 2, which will give you 5.487 into 10 to the power 6. So RP will be 5.487 into 10 to the power 6 meter inverse. So is this clear to you? So this was basically a simple question where we replace the mass of electron with mass of positronium, because initially there was only single electron that was moving, but here there are two particles that are moving related to each other. That is, one is electron, another is positron. So is this clear to you?
Yes, sir.
Okay, so now we'll move to the next question, that is question number 5. It says, what is the de Broglie wavelength of a ping pong ball of mass 5 gram after it is slammed across the table with the speed of 2 meter per second? The options, these are the options. I am not going to read it. You can see in the screen. So all answers are in Armstrong. So when you are calculating the de Broglie wavelength, keep that in mind. And also, so before we have discussed about the relativistic and non-relativistic motion. So can anyone tell me whether this is the case for relativistic motion or non-relativistic motion? Yes.
No question is displayed, sir.
Non-relativistic, sir.
So can you see the screen now?
Yes, sir. Now it is available.
Okay. So the question is, the de Broglie wavelength of a ping pong ball is 5 gram, and after it is slammed across the table with the speed of 2 meter per second, what will be the de Broglie wavelength? So mass is given, mass is 5 gram, and the velocity is 2 meter per second. Yes, what you are saying, it was correct. It is the case of non-relativistic case, because you can see, if you compare it, the velocity with the speed of light, you will get the value of velocity is very less than as the velocity of light. That's why the case is the non-relativistic case. So according to non-relativistic case, we know lambda is given by h by mv. So we know the value of h. H is 6.62 into 10 to the power minus 34 divided by m. M is 5 gram. So in order to convert it into kilogram, we will multiply by 10 to the power minus 3, then 2 meter per second. So it is 2. So if you calculate it, it will give you 6.626 into 10 to the power. So the 5 into 2 is 10. So it will be 10 to the power minus 2. 10 to the power plus 2, it will be 10 to the power minus 32.
Sir, there may be confusion, sir, little.
1 minute. Yes.
Sir, there may be confusion because these what we are discussing these problems.
Yes.
These are already yesterday discussed by Manav.
Okay. Actually, since so basically we two
No,
are
we,
the
we
PMRF TAs of this course. So our duty is to solve the questions.
okay.
Solve the
No,
questions that are
no. Sir, little method is different, but the problems are repeating same only in
exactly.
sequence order.
Exactly. I
Okay.
am saying the same thing.
Okay.
So our duty is
Okay.
to solve the questions that were related to the uh, that was basically uh, the questions of old
Okay.
assignments and so basically
Okay.
the why there are two TAs. So since there are a large number of students, so some will be joining in that and some will be joining in this. So
Okay, sir.
But
anyway,
this
Sorry,
is
sorry,
very
sorry, sir.
easy.
I don't
no
know
sir,
much more about this one. This was my
no
first
no the
session. I
it's
had
okay, but I am finding it quite obvious that since both are solving same problem and also you are attending both, so I will try to solve new problems rather than apart from these problems in the next class.
no, okay, no
But,
issues.
this method seems to be very easy, sir. Thank you.
Yes, yes, sir. So yes, so can anyone tell me what will be the correct answer? So it is 6.626 into the minus 32. What will be the unit? Yes. So the unit will be meter because all we have taken in SI units. So if you want to convert it to Armstrong, what will be the factor? 6.626 into 10 to the power minus 32. 1 meter is how many Armstrong? 10 to the power 10. We had discussed in the previous question. Na? So 1 meter is 10 to the power 10 Armstrong. So the correct option will be, or the correct answer will be lambda is 6.62 into 10 to the power minus 32 into 10 to the power 10. So it is 6.62 into 10 to the power minus 22 Armstrong. So the correct answer is 6.62 into 10 to the minus 22. So as you can see, all these options are not correct. So I think there must be some printing mistakes. So all these options are
Yesterday
not
they
correct.
have removed angstrom only. They removed, sir, everything.
Yes, yes. So
Manav.
either you remove Armstrong or you remove the values. So so the correct answer will be 6.62 into 10 to the power minus 22 Armstrong. So as long as you know how to solve these questions, whether the options are right or wrong, it's not in our hand, but If we know the method of solving it, then it's fine. Okay, so we'll now move to question number 6. It says the degree of degeneracy of the nth energy level in the hydrogen atom is option A. Option A is n square. Option B n by 2. Option C n into n plus 1 by 2. And option D root n or n to the power half. So can anyone tell me what will be the correct option? So can anyone tell me what do we mean by degeneracy?
Means, degeneracy means same energy level having, sir.
Yes. Then
Same energy level. I don't know much more. I think.
so basically, if you see, this degeneracy concept comes when we introduce additional quantum numbers, for example, azimuthal quantum number, orbital magnetic quantum number, and spin magnetic quantum numbers. However, here we will only since these questions are related to Bohr-Sommerfeld theory. So according to Bohr-Sommerfeld theory, there are only two quantum numbers known to us. One is azimuthal quantum number L, another is principal quantum number N. And we know corresponding to one value of N, there are how many values of L? Yes, so for one value of N, how many values of L we have?
One only, sir.
No, for one value of N, L can have L can have N values, and that will be, suppose this is N, and L will be 0 to N minus 1. So suppose N is 4, then L will be 0, 1, 2, 3. Is this clear?
Yes,
Yes,
sir.
sir.
Okay, so no, can you say me why you are saying 1 it will be only? So basically, if you see during Bohr's theory, he said that the electrons are evolving in stationary states, and the energy remains the same. However, if we talk about the modifications done by Sommerfeld, he said that for a particular value of energy, there are more than one level, because as long as the value of n remains the same, the value of E or the energy will remain same. But according to the quantization rule, a new quantization rule that Sommerfeld gave, it was found that there are two quantum numbers, because the orbits are not circular, they are elliptical. So when they are elliptical, there are another component of angular momentum, that is orbital angular momentum. So one is principal quantum number, another is orbital azimuthal quantum number. So under that case, for a particular value of n, L will be having different values. So for a particular value of n, L has again n values, and the values are 0 to n minus 1. So if the value of n is 4, then L has 0, 1, 2, 3. So if n is 4, then there are 4 levels, and each level the value of L is different. However, as long as n remains the same, the energy for all these levels remains the same. That's why the concept of degeneracy comes into picture, because degeneracy means there are different levels, but they have similar energy. Those energy levels are called as degenerate energy levels. So energy levels, different energy levels having same energy value is called as degenerate levels, or are called as degenerate levels. So if we talk about that, we know again for corresponding value of L, what will be the there are NL values, or sorry, ML values, is not it? So corresponding to one value of L, there are 2L plus 1 ml values. Basically, see, this is the so since there are we have not till discussed about these ML values, how the ML values are coming to picture, but in general, but from the concepts we have discussed L has, so for a particular value of L there are 2L plus 1 values. So when L is 0, ML has 1 value. When L is 1, there are 3 values of ML. So L is 0 means ML is 0. 3 values means ML is 0 plus 1 minus 1, and for 2 it is 5, then ML will be 0 plus minus 1 plus minus 2, like that. So since you see, if all these corresponds to a particular, suppose there are number of labels and all these labels corresponding to a particular value of n, suppose n is 2, so as long as n is 2, so sorry, here n can be 2 because we have taken L equal to 2. Suppose n is 3, so as long as n is 3, these labels are different because L is equal to 0 is one label, L is equal to 2 is another label, L is equal to 1 is another label. So these labels are different because their notations are different. However, since the value of n is same, all the labels have same energy. That's why they have the degeneracy, or they are degenerate labels. So under that case, how we will calculate the degeneracy? So we know for particular value of n, L can have values from 0 to n minus 1, and for a particular value of L, there are 2L plus 1 levels. So basically, by degeneracy of the degree of degeneracy means how many number of labels are there for a particular value of n. Is this clear to you?
Yes,
Yes,
sir.
sir.
So now we will calculate if there is a n value, then how many number of labels can be, or can be possible for a particular n values. So how we will calculate? We just discussed, for a particular value of n, there are L values that ranges from 0 to n minus 1, and for a particular value of L, there are 12 plus 1 values. So total number of labels for n will be how much? So it will be summation over L, because for a particular value of L, for particular value of n, L is 0 to n minus 1. So L will be 0 to n minus 1. And for each value of L, there are 2L plus 1 levels. Is that clear? So what will be? So it will be 2L plus 1 for L equal to 0, plus 2L plus 1 L equal to 1, plus 2L plus 1 L equal to 2, up to 2L plus 1 L equal to n minus 1. Is this clear?
Yes, sir.
Okay, so if we calculate, let me add another slide. So if we put this value, suppose L equal to 0, then it will be 1, L equal to 1, it will be 3, L equal to, it will be 5. So the sum will be 1 plus 3 plus 5 plus, for L equals to n minus 1, it will be 2 into n minus 1, 2 into n minus 1 plus 1. So it is 1 plus 3 plus 5 plus 2n minus 1. So can you tell me how many number of terms are this in equation? This equation. So if we go from 1, 3, 5 up to 2n minus 1, how many number of terms are there in that particular equation? So 1 plus 3 plus 5 plus up to 2n minus 1. So it will be how many terms? So the number of terms is equals to number of L values, is not it? Because here
Okay.
we made the summation from L equal to 0 to n minus 1. So if there are 5 L values, there will be 5 terms in that summation. If there are 10 L values, there will be 10 sums in the summation. 10 terms basically, sorry. So since the L value is 0 to n minus 1, So how many L values are there? So how many L values? 0 to n minus 1 means 0, 1, 2, 3 up to n minus 1. So it will be n values, is not it?
Okay, sir.
Are you getting that? So 0 is one value, 1 is second value, 3, 2 is third value. So like that. So if we are starting from 0 and counting up to n minus 1, these are actually n numbers, is not it? Because 0 is not the value of n. 0 is the value of L. N can't take the value of 0. Because
Yes,
if
sir.
we are
Yes, sir.
if we are taking the value of why n can't be 0?
Because it may be the ground level.
Because when so actually this concept is related to quantum mechanics, we will discuss that in questions. But you see, if we are putting n equal to 0, then it will lead to similarly also from the energy expression you can say the expression is z square by n square, is not it? The relation that we have for ground state energy of hydrogen atom, it is minus 13.6 z square by n square. So when n is 0, then 1 by 0 is infinity, then energy also can be infinity. Again, if we talk about from perspectives of quantum mechanics, we will see in upcoming weeks that when the value of n is 0, the total wave function of the particle is 0. So when the wave function 0, the particle is not present there. So when the particle is not present there, then that can be considered as a energy state. That's why n can't be 0, n will start from 1. So here there are n terms. So 1, 2, 1 plus 3 plus 5 plus 2n minus 1. So now you understand. So these are n terms. Is this clear?
Yes, sir.
So now this is a arithmetic progression series. So for that series, if we are adding 1 plus 3 plus 5 plus up to 2n minus 1, so the maximum value here is n minus 1. This is the case. So this was n minus 1. So the formula is n by 2 into 2a plus n minus 1 into d. So n minus 1 means this n minus 1, and n is n terms. So here n is number of terms, a is the first term, and d is the difference between two successive terms. D is difference. So now we know difference is 2 here, 1 plus 2 is 3, 3 plus 2 is 5. So difference is 2, first term is 1. So if we calculate it, it will be n by 2 because there are n terms. N is number of terms, and here number of terms is again n. So we can suppose we can write it t. So this is t. So t is number of terms, and number of turn here is n. So number of term is n. So n by 2 into 2 into 1, because a is the first term, plus n minus 1 into d. D is difference, that is 2. So if you calculate, it will be n by 2 into 2 into 1 is 2 plus n minus 1 into 2. So it will be 2n minus 2. 2n minus 2. It will be n by 2. These 2 gets cancelled. It will be 2n. Then 2 again gets cancelled. It is n square. So this is the degree of degeneracy. Suppose this is g. So the degree of degeneracy, is g. Suppose it is g and it is n square. So is this clear to you?
Yes, sir.
Yes, sir.
Okay, so I hope this is clear to you. However, if you see in actual case, if we discuss, this g is not n square, it is 2n square, because here we are calculating its n square. Can you tell me why 2 is not coming here?
Where, sir?
Because the 2 comes from the degeneracy due to the spin motion of electron, and we know the spin value of electron is half, and according to spin values there will be spin degeneracy, like L has 2L plus 1 values, S has 2S plus 1 values. So for S equal to half, 2S plus 1 will be how much? 2. So for particular value of, since for all since we are talking here, we are talking about electron. So electron has value of S is half. So if we add another term here, so it will be 2S plus 1. So this term 2S plus 1 gives the factor 2 here. So in actual case, the degeneracy of electron, including or considering the spin motion of electron, is 2n square. However, if we are not considering the spin motion of electron, the degree of degeneracy is n square. Is this clear?
Yes, sir.
Okay, so now we will move to the next question. Question number 7. Question number 7 says, calculate the speed of revolving electron in hydrogen atom in its fast excited state. Options are: option A 2.2 into 10 to the power 5 meter per second, option B 3.7 into 10 to the power 5 meter per second, option C 10.9 into 10 to the power 5 meter per second, option D 5.4 into 10 to the power 5 meter per second. So we had discussed the expressions for orbital velocity, orbital radius, and energy in the previous session. So does anyone remember what was the expression for speed or orbital velocity? Vn. It was Jd square by 2 epsilon 0 nh, and this was in meter per second. So we know we are talking about hydrogen atom. So Z is 1 for hydrogen atom. Then epsilon 0, we know the value of epsilon 0, it is 8.854 into 10 to the power minus 12. Then n is the principal quantum number, and the value of principal quantum number for fast excited state. For ground, what will be the value of n for fast excited state? Yes, it will be 2, because for ground state the value of n is 1, for fast excited state the value of n is 2. Now h, we know it is Planck's constant, 6.64 into 10 to the power minus 34 joule into second. And if you talk about the formula for epsilon 0, it is Coulomb square by Newton into meter square, is not it? So if we put all these values, so Vn will be Z is 1, E square means charge of electron 1.6 into 10 to the power minus 19 square, 2 into epsilon 8.854 into 10 to the power minus 12 into n is 2 into h is 6.64 into 10 to the power minus 34. So the correct answer will be 10.9 into 10 to the power 5 meter per second. So the correct answer is option C, 10 to 10.9 10 to the power 5 meter per second. Is this clear to you?
Yes, sir.
Okay. So now we will move to question number 8. Question number 8 says, in Sommerfeld's modification of Bohr's atomic theory, if k is the azimuthal quantum number, nr is the radial quantum number, and n is the total quantum number, then what is the relationship between k, nr, and n? So nr into k is n, k divided by nr is equals to n, k plus nr is equals to n, and k minus nr equal to n. So I would like you to think about it, and then we will discuss what will be the correct option according to Bohr-Sommerfeld theory. Yes, so can anyone say me what will be the correct answer?
Sir, is it A?
No, it's not A.
C1, sir.
Yes, the correct answer is option C. That is N is equals to the sum of K and NR. So now these NR and K that comes into picture due to the quantization, because quantum numbers, the name quantum number implies that they are related to quantization of quantities. So like N was related to the labels. Now here similarly, according to Sommerfeld's theory, he said that he stated two new quantization law, that was integration PRDR equal to NRH and P theta 0 to 2 pi P theta D theta equals to KH. So here N was radial quantum number, K was azimuthal quantum number, because this is radial, this component is correspond to radial motion and this is azimuthal motion or the orbital motion. So if you talk about this due to the introduction of this new quantum number, it was found that actually the uh, label or the orbit of the electron, that it is revolving around the nucleus, is not circular. It's not always circular. It is rather than it is elliptical. So that's why corresponding to one particular value of n, there were more than one values of L. So from there we got an idea about the nature of the shape of the orbits, and it was found that the shape of the orbit is ellipse or elliptical orbit. And for ellipse, we know the relation was given by B by A is equals to K by NR plus K, where B was semi-major axis and B was semi-minor axis, A was semi-major axis. And for ellipse, the value of K is not equal to 0, because when you see the value of K is 0, then B by A is 0. B by A is 0 means it is no longer an ellipse, it is a straight line, and it will pass through the nucleus, is not it?
Yes, sir. Yes, sir.
So when suppose so this is ellipse, so this is B and this is A. Now if A is suppose is K is 0, then this B by A will be 0. So B by A is 0 means A is infinity and B is 0, is not it? So when K is equal to 0, then B by A is 0, is not it? So B by A is 0 means either A is infinity or B is 0. So in that case, so if an ellipse has semi-major axis infinity and there is no semi-minor axis, then it is basically a straight line. And that straight line, we know the according to the theory, the electrons are revolving and the nucleus is present at one of its focus. So the focus will or the straight line will pass through that focus. So under that case, when the orbit is a straight line, then it will pass through the nucleus. So when the electron is revolving in that orbit, it will again pass through the nucleus. And we know, according to the experiments or according to the various statements given by the scientists, we know that the electron can be present inside the nucleus, because if the electron is present inside the nucleus, then there are many violations related to the energy of the nucleus or some other things. So for that, the value of K is not equal to 0, because the ellipse will become straight line. So under that case, the value of K becomes 1, 2, 3 like that. However, the value of NR can be 0, because you see when NR is 0, B by A still has values, non-zero values, or they are feasible values. So under that case, NR can be 0. So NR is 1, 2, 3 like that, and N has the values 1, 2, 3. 3, like, because these are principal quantum numbers. So under that case, since k can't be 0, so if you see the relationship between these values, so it comes out to be n is equals to nr plus k. As you can see here, 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2 is 3, like that. So the correct option is option C, that is n equals to nr plus k. So again, k has n values, nr has n values, and the sum is given by the total quantum number. So the name also implies n is the total quantum number. Total quantum number means sum of the two quantum numbers. Is this clear?
Yes, sir.
Okay, so now we will move to the next question, that is question number 9. Question number 9 says the wavelength of the fast Balmer line H alpha of hydrogen is 6563 angstrom. Calculate the wavelength of the same line for tritium, that is 1s3. Options are option A 6560.6 angstrom, option B 6563 angstrom, option C 6572.4 angstrom, and option D 6620.5 angstrom. Yes, so can anyone tell me what will be the correct option? See, so here we need to find out the fast Balmer line. So can anyone tell me when Balmer line appears in hydrogen? Basically, what are the levels from which, if the electron is getting the transition, fast line of Balmer is or will be appearing? So when electron, the transition of electron is from 3 to 2, then fast Balmer line appears, that is H alpha. So if you talk about the wavelength of that transition, it is given according to the Bohr's theory. It is RH 1 by n1 square, that is 2 square, minus 1 by n2 square, that is 3 square. So it will be 5 by 36 R into H. Similarly, if we talk about, this is for hydrogen atom. However, if you talk about the case of tritium, 1 by lambda T will be 5 by 36 R T, because again, if you are talking about Balmer series, these N1 and N2, they will be remaining the same. However, since there are two different nucleus, their Rydberg's value will be different. So if we calculate the value of Rydberg's constant for tritium, definitely it will be different from that of hydrogen. And we know the expression between the value of Rydberg's constant when it was calculated, assuming that the nucleus has infinite mass, and when we consider the mass of nucleus is finite, then in that case, considering the mass of nucleus is finite, the expression is R alpha divided by 1 plus small m divided by capital M, where small m is
No,
the
it's
mass
it's
of,
it's
sorry,
not.
sorry.
No, sir, no, sir.
Okay, so small m is the mass of electron and capital M is the mass of nucleus. So since here the mass of nucleus is different for hydrogen as well as tritium. So for hydrogen, the mass of nucleus, since in hydrogen it has only one proton in its nucleus. However, for tritium it has one proton and two neutrons. That's why the mass of tritium is tritium is written at 1s3. So it is one of the isotopes of hydrogen. So in that case, if we calculate, then the Rydberg's value will be different for tritium. So basically the ratio of those transitions, that is lambda h divided by lambda t, it will give us lambda t equals to lambda h into 1 plus small m by capital M tritium divided by 1 plus small m by capital M hydrogen. Because in case of Rm, we can put Rt and Rh. So if you put these, then lambda t by lambda h, it will be 1 plus m by m divided by mass of the tritium nucleus. Then on in denominator it will be hydrogen. So if you calculate, we know the wavelength for hydrogen is given to us. It is 6563 angstrom. 6563 angstrom. Then 1 plus mass of, if we talk about the relative mass or the comparison of mass of electron as well as proton. So we know proton is 1836 times heavier than the mass of electron, and here we can assume that the mass of proton and mass of neutron both are equal. So in that case it will be 1 by 1 by, for tritium case it will be 3 into, because there are 3 or 2 protons and 2 neutrons and 1 proton, it will be 3 into 1836 divided by 1 plus 1 by 1836. So if you calculate it, it will give us 6563 into 3 into 1836 plus 1 divided by 3 into 1836 plus 3. So it will give you 6560.6 Armstrong. So the correct option will be option A. So as you can see, due to if you are assuming infinite mass of nucleus, then the Rydberg's value will be same, or the Rydberg's constant will be same. However, if you are not assuming the infinite mass of nucleus, then due to different mass of nucleus of hydrogen and tritium, their transitions or the wavelength correspond to the transition of electron between same two levels, because as you can see, for both case n1 is 2 and n2 is 3. However, due to difference in the value of Rydberg's constant, we are getting different values. So is this clear to you? Yes.
Yes, sir.
Yes, sir. Yes, sir.
Okay, so now we will move to question number 10, which is the last question of today's session. The question says a positonium atom in a system consisting of a positron and an electron. Given mass of electron is 9 into 10 to the power minus 31 kg, mass of proton is same as that of the electron, and charge is also same as that of the electron but positive. If the ground state energy of hydrogen is 13.6 electron volt, then the ground state energy of positonium will be how much? Options are option A minus 13.6 electron volt, option B minus 3.4, option C minus 6.8, option D minus 1.51 eV. So if you remember the expression for energy, so can you tell me what was the expression for energy? Y minus 1 by 8. Yes. What was the expression for energy of hydrogen atom? Sorry, energy of electron in hydrogen atom. It was, sorry, m z square e4 divided by n square h square epsilon 0 square. Is not it?
Yeah.
So
Okay. Yes, sir.
here you see, if we talk about the case of electron and positron, all have the same values, only the change here will be mass, because for electron the mass is me, that is 9 into 10 to the power minus 31 kg, but for positron the mass will be, the mass of positron is me by 2, that we have already discussed in the previous question that we solved. So it is due to the reduced mass concept, reduced mass. So under that case, if you put in place of m, it will get replaced by m by 2. So in that case, EP will be 1 by 2 into EH. Is not it? Because m is getting replaced by m by 2. So if you put here m by 2 and all other values remains the same, as long as you are talking about uh, the charge of electron is same, Z will put here 1 for hydrogen, and then n is remaining the same because the ground state, we are talking about the ground state, and then h and e0 they are universal constants. So the new energy will be 1 by 2 into the ground state energy of hydrogen atom, that is minus 13.6 electron volt. It will be minus 13.6 divided by 2, which comes out to be how much? Minus 6.8 electron volt. So is this clear to you?
Okay, sir. Yes, sir.
Sorry.
Okay, sir. Clear.
Okay, so basically these were the questions that I wanted to discuss with you. So in the next interaction session, we will be solving a few problems that will be based on the week uh, 4. So week 4 course contents, and also I will try to solve different questions at that of the question that as being that that are being solved by my colleague. So with this,
One more request, sir.
yes.
Sir, can we get any notes for regarding this one chapter, theoretical as well as formula related?
So
We have to
uh,
discuss in that forum only, or will help you?
no, no, no. So all the contents that I
Because
am
we are getting only videos classes
exactly,
there,
exactly. So
but
let me
some concepts are we are not getting, especially Anmol sir what I are taking. They are not to the points are not clearing my doubts.
where
I have go
sorry.
through some of the videos.
Sir, exactly what we are saying means, suppose without this live interaction means only using those weak videos, we couldn't answer the assignment, sir. Only on behalf your interaction only, we are getting the answer somewhat. So we are coming to know
Yes.
how to solve the problems. If this live session is not available means, we will be feeling very tough. And what we find is many informations are there, and we have to come across continuously, and after 12 weeks means we will forget the first 2 weeks
No,
information,
that
so
no,
if we
that I
get
can
it.
understand.
So any
So
PDF notes are available anywhere so that we can download.
PDF notes of what? So the best way to understand this concept is to read books. You must have
Uh,
watched the lectures. So in the lectures, professor suggested a few books like Branson and Joachim and all those
sir,
things.
it's
Yes.
okay. At instant of time we are unable to get it, sir.
Okay. So no,
So
that's
that
like
we have.
so. Actually, the level of understanding that you will develop with time. So as you learn
Okay.
new things, so with time you will try
Mm.
to analyze the things, and we also try to correlate the things that you are studying. So like I
Okay, sir.
discussed, so the concept of single electron atom can be again correlated to the concept of fine structure and hyperfine structure. So all these
Mm.
things with time you will develop it. So so however
Okay.
for current course you just you can also post
Mm.
your doubts in the discussion forum. However, it will be better if you can state your doubts to me. Then I will be
Mm.
trying to explain you according to my
Oh,
level of understanding.
okay. Okay. Okay, sir. No issues.
And see, so you are joining for the first time today.
Yes, sir. Last video, what sir taken, and today video only two live
So
session.
live session what?
And enrolled this time only first time for in the
Okay.
NPTEL course.
So
Uh,
what you can do? So basically, I also before this session, in the last two sessions, I was adding a particular slide that to contain the informations of the course. So what I am doing, I am taking the class and the recordings of the course and the the materials that I am solving here, the presentation files or PPT files and the PDF files, that I am uploading in a folder in my Google Drive, and that folder link will be shared with you by NPTEL. I think it must have been shared with you.
and okay,
Yes,
no
sir. To
issues about
YouTube
this
link not there,
numerical,
sir.
sir. And just I need some of the extent to basic concept so that if
Okay, so
theoretical
one
complete basics clear means we can easily solve the problem.
exactly.
My
So
opinion.
one thing you can do, I would suggest to read. Concept of Modern Physics by Arthur and Weiser. You know that book?
No,
Modern
sir.
physics, right?
Arthur Weiser. Arthur Weiser, Arthur, Weiser,
Yeah,
Beiser.
Okay, sir,
ARTH.
we'll download.
So actually, this book is an excellent book for understanding the concepts, basic concepts, and almost it covers almost all aspects like quantum mechanics, atomic physics, some part of modern physics like this atomic structure, nuclear physics again. So you can also read that book, and we'll discuss in more details in the upcoming weeks.
Okay,
Okay,
sir.
sir.
Okay, so just wait a minute. Let me stop the recording.
Okay, thank you very much, sir.